Hello and welcome back. In last video we discussed the linear sequence in detail, and in today's video we are going to discuss the quadratic sequence in detail. So let us start. As we have already discussed that the linear sequence is one where the first difference sequence is a constant sequence, and the quadratic sequence is one where the second difference sequence is a constant sequence. Here we have taken an example of a quadratic sequence, and first we are going to generate the next two terms of this sequence, and then we are to determine the nth term formula for this sequence. First of all, let us discuss the nth term formula for a quadratic sequence. As we have discussed the nth term formula for a linear sequence, it was, in case of a linear sequence, the nth term formula was Tn is equal to a plus d times n minus 1, where a was the first term of a sequence and d was the common difference or the difference of constant sequence. Now in case of a quadratic sequence, it is, because we know there are two differences over here, so it will be Tn is equal to again a plus d1, it is the first term of first difference sequence, times n minus 1 plus d2 divided by 2 times n minus 1 multiplied with n minus 2. Here d2 is the first term of second difference sequence if it is a constant. So now first see the next two terms of this sequence, and in order to generate the next two terms of any sequence, we observe the pattern of the consecutive terms, like 3, when we add 3 to it, it becomes 6. When we add 5 to 6, it becomes 11, and when we add 7 to 11, it becomes 18, and 18 plus 9 is 27. So we can observe that the term being added is increased by 2 every time. So the next term will be 27 plus 11. So that shall become 38, and the term after that shall be 38 plus 13, that shall become 51. So the two terms after the given five terms are 38 and 51. Now as we see, and this is the first difference sequence, 3, 5, 7, 9, 11, 13, and it is not a constant sequence. So let us take the second difference, and that is 5 minus 3, which is 2, 7 minus 5, it is 2, 9 minus 7, it is 2. So it is a constant sequence, and we will call this second difference d2, and the first term of the first difference, it will be d1, while the first term of the sequence is always a. So here we have the values of a, d1 and d2, and we will replace it in the formula we discussed, and that will generate us the nth term of the sequence given. So here we go. It was a, which is 3 over here, plus d1 is again 3 times n minus 1, plus d2, we know it is 2, divided by 2 times n minus 1 multiplied to n minus 2. Now let us simplify it, that 3 plus 3 multiplied to n minus 1 shall become 3n minus 3, and here if we cancel 2 with 2, so it is only the product of n minus 1 and n minus 2, and that is like n square minus n and minus 2n shall become minus 3n, and minus 1 multiplied to minus 2 shall become positive 2. Okay, now here we can see that 3 is cancelled with the minus 3, positive 3n is cancelled with the minus 3, and we are left with n square plus 2. So this is the formula for the nth term of the sequence given, and we see it is a quadratic expression in n, so it was a quadratic sequence definitely. So that was the uh, nth term formula for a quadratic sequence. We always write the nth term formula for the quadratic sequence in comparison with the linear sequence. Okay, as we see, the nth term formula for a linear sequence was a plus d times n minus 1, and the nth term formula for the quadratic sequence is a plus d1 times n minus 1, d is replaced with d1, and because it is a quadratic, it will be like d2 divided by 2, and n minus 1 was already there, and we multiply n minus 2 with it, n minus 1 into n minus 2, and that is for the nth term of the quadratic sequence. Now let us discuss another question, and that will explain more about the quadratic sequences. Okay, now see this question. It states, consider the sequence 0, 3, 10, 21, 36. Show that this sequence is quadratic. So in order to show that it is a quadratic sequence, we will prove that its second difference sequence is a constant sequence. So let us write the term first. 0, 3, 10, 21, and 36. Now take the first difference sequence. 3 minus 0, it is 3. Then it is 10 minus 3, which is 7. 21 minus 10, it is 11, and 36 minus 21, it is 15. As we see, the first difference sequence is not constant, so it is not a linear sequence. Now take the second difference. 7 minus 3, it is 4. Then 11 minus 7, it is 4, and 15 minus 11, which is also 4. As we see, the second difference sequence is a constant sequence, so it is a quadratic sequence. So it was the first part where we had to show the sequence is quadratic. Now in second, it said find in terms of n formula for the general term of sequence, and we know formula for the general term of a quadratic sequence is that a plus d1 times n minus 1 plus d2 divided by 2 times n minus 1 into n minus 2. So here we know a is the first value of the sequence, d1 is the first term of first difference, and d2 is the first term of second difference. So just replace the values over here. A was 0 plus d1 was 3 times n minus 1 plus d2 was 4 divided by 2 times n minus 1 into n minus 2. So as we see, it is 0, so we can skip it. 3 multiplied to n minus 1 shall become 3n minus 3, and we see 4 divided by 2 is 2, so we will multiply 2 with the product of these two terms. N minus 1 times n minus 2 shall be n square minus 3n plus 2. So we multiply 2 to it, and that shall become like 2n square minus 6n plus 4, and here we have 3n minus 3 as well. So let us simplify it, and we will have our answer of the nth term of this sequence. So it is 2n square because there is only quadratic term. Then it is plus 3n minus 6n, so it shall become minus 3n, and here is minus 3 plus 4, so it will be plus 1. So this is the nth term or the generator formula for the given sequence. Now if we see the third, it say hence find the difference between the 80th and 81st terms. So in order to find the difference between the terms, like we have to find the T81 minus T80. So T81 mean we are going to replace n with 81. So it shall become 2 times 81 square minus 3 times 81 plus 1 minus T80 is 2 times 80 square minus 3 times 80 plus 1, and then we can find the answer by using a calculator. So it is T81 minus T80, which equals it is 319. So 319 is the difference between the consecutive term 81st and 80th terms. Okay, here we have another question. It states the nth term of a sequence is given by 2n square plus 1. Write down the first four terms of the sequence, and we know in order to generate the first four terms of the sequence, we will replace n with 1, 2, 3, and 4 respectively. So when I replace n with 1, it becomes 1 square times 2, it is 2 plus 1, which is 3. 3 is the first term. Then we replace n with 2, so it is 2 square. 4 times 2, 8 plus 1 is 9. Then the third term will be 9 times 2, it's 18 plus 1, 19. And the term after that shall be 4 square, which is 16 times 2, 32 plus 1, it is 33. So these are the first four terms of the sequence defined by this formula 2n square plus 1. In B part, we can see it is the first four terms of another sequence are given 1, 7, 17, 31. And it said by comparing that sequence with that sequence in part A, write down the formula for nth term of the sequence. So first of all, write the two sequences over here. The first sequence was 3, 9, 19, 33, and the second sequence is 1, 7, 17, and 31. So as we see, the nth term of this sequence was 2n square plus 1. And as we see, the second sequence is basically we subtract 2 from the first sequence. Whenever we subtract 2 from the term of the first sequence, we get the second sequence. We can verify it with any term. So it is basically when we will subtract 2 from the nth term of first sequence, we will get the nth term of second sequence, and that shall be 2n square minus 1. So the nth term formula for the second sequence is 2n square minus 1. And in second part it said hence find 38th term of the second sequence. So it is like t38, which becomes 2 times 38 square minus 1. So we will use calculator, and the answer to it is 2887. So that should be the 38th term of the sequence in part B. Here I have given you a little task. It is a sequence with terms -1, 1, 5, 11, and 19. And in first part, we have to find the nth term formula for the sequence. And then using that formula, you have to figure out the difference of 30th and 20th term of this sequence. So calculate it and write your answer in comment section.